次のセッションは、はい。アレクサンダー・コーゾフさん。ちょっと英語でお話しいたします。Next session is by Mr. Alexander Kozlov, CloudBEAR. Our title is Use Case for RISC-V Processor IP Commercial Cores for Real Life. And so Mr. Alexander Kozlov is a co-founder and CTO of CloudBEAR company. He has more than 15 years experience in developing software hardware solutions based on FPGA and ASIC design. And he has a good experience and master degree on the St. Petersburg State Polytechnical University. So, and he studied ASIC design engineer, then moved to algorithm and hardware architecture research. And he has focused on microarchitecture algorithm code design in telecommunication and multimedia processing systems. Before CloudBEAR, he held various engineering management positions in other companies. So, just on time to start presentation. Mr. Alexander Kozlov, will you start your presentation?
Yes, thank you. So my name is Alexander Kozlov. I'm a CTO at CloudBEAR. So I'm happy to present you about use cases for RISC-V processor IP. Today I will present about the use cases which we meet during our work with customers and give you examples how customers are using the cores and which features they ask. So at least I will talk about the public examples which I'm allowed to talk in a certain level of details. I will less talk about our product portfolio today, since there are several available presentations on recent RISC-V events, so which you can find on RISC-V International YouTube. So there is more details on the course itself, benchmarking and so on. But anyway, I would like to briefly mention which products we have to the day. So we have 3 cores series. The first is the M series, which targets small and efficient MCU cores. It's represented by BM310 32-bit microcontroller core and its 64-bit version BM610. Second series is the R series, which are fast and compact embedded cores. Then I say fast, I mean cores which could be clocked above 1.2 gigahertz at modern technology nodes. And the R series includes 2 cores at the moment. So both are dual issue, 9-stage pipeline cores. And the difference is only that one is a 32-bit BR51 and another one 64-bit BR651. This course targets high-performance control application, acceleration and offloading functions and system on chips. And what is shown at the bottom of the slide is the I series. It's our Linux-capable application processors, which scales from tiny IoT-level core BI350 to mid-range autophoto core BI671, and in the middle there is power-efficient dual-issue BI651 core. So moving to the applications which we face with customers. So initial wave of customers were asking us about simple cores for control applications where core itself doesn't touch the data and focus more on control and management functions. So typically in these scenarios, there are several IP cores which should be controlled by the core to allow to enable flexibility. So in this case, cores are doing configuration and state machine-like job. Examples we face are some video processing chains, AI acceleration control, wireless baseband controlling. So in these cases, customers typically asking for simple configuration like RV32 IMC configuration. And in more complex scenarios, we saw that core do not only state machine-like job, but run complex management software, like in SSD controllers to do processing on NVMe software, flash transaction layer, or implement caching algorithms. In wireless Mac application, core do packet processing, control accelerators like crypto, and manage the host interface. In these cases, more featured configuration were required. So needed of atomic operation is used to speed up critical section in real-time operation system to communicate between cores. And B extension is effective to process a bit field in the headers or payloads in storage or communication protocol. And CloudBEAR is already support latest draft of B extension version 0.93, and we support it both in toolchain and in hardware. Depending on performance needs, customer selects BM310 or BR351 core, so which allow you to use a more high performance core or more low area and low power core. In deeply embedded applications, which I have shown on the previous slide, typically chip users don't see core from outside world. And in many use cases, you don't even know that RISC-V is inside. But now I will move to the cases where cores are visible to the users and fully programmable. So our public customer, Melander, is building a new generation of IoT system for smart metering applications based on RISC-V. Melander is not only chip company, which is they are not only selling the chips itself to the end user, but also system company building own equipment and software. Overall system has 3 layers. So simple meters like water, gas, electricity meters are powered by small microcontrollers, and they measure the data and from the sensors and transfer it to the secure gateways, which already provide data to the cloud, and there is some software on the user side which can allow to manage that, analyze that, and so on. So in this product will be 2 processors which will use RISC-V based on our cores. So first, secure microcontroller, which is based on BM310. It's already available for the customers, and I will show in details in the next slides, talk about this chip. And currently under development on the last phase is a Linux-capable processor, which will be based on dual-core BI671 auto for the CPU and using BR351 as a management and security providing processor. So the chip for smart metering is already available. So this is already available since autumn 2020, and now already deployed to the several customers which plan to use it in the mass production devices. And this summer, this chip will start the mass productions, and the plans in the next year starting shipping already several hundred thousands of these chips. So the chip itself what target from the customer perspective, what target very high volume and low price units. So they do a lot of work to reduce the price itself. But in smart metering devices, the requirements for calculations and for communications are growing, and they need the more powerful CPU. In first generation, Milan were using ARM Cortex-M0, but in new generation, they care to improve performance, and they need performance better than Cortex-M4, which actually we were able to provide with our BM310 solution. So our BM310 was ideal choice. So we provide RV32 IMC configuration. This is a three-stage pipeline. Customer asked us about a parallel multiplier to do some calculation work more fastly, and adding debug features, especially hardware triggers to enable debugging in the embedded flash memory. Itself, chip is about a 10 millimeter area, but core consumes only 0.3 millimeter, around 0.3 millimeter, which is less than 3% of the area. Chip itself has a lot of security features, so specialized ADC for smart metering, secure storage, crypto, and other tamper detection protection features. So yeah, evaluation boards are already available for this chip, and moreover, there is some board which typically used by smart metering developers, which has ADC converters inputs, but as well there is a simple board for makers who want to try our the chip itself and our course especially. So it's based on Arduino compliant standard, and also has some well-known PMOD connectors, so you can connect a lot of available stuff to this chip. And this board are available for CloudBEAR customers as well, so for evaluation of the core. So if you like, you can have it from us during the evaluation process. And I hope, and we work on this customer on that port will be also more widely available for other people who want to prototype something with the RISC-V. So as I told, there is debug modules which we support, and we support recent specifications. And we always do interoperability checks with third-party ecosystem vendors which are developing the tools for programming and debugging the software. So we have interoperability tests with ER, Outerbach, Ziegler, and so you can easily use these EDs, these commercial EDs, to program your course. But at the same time, we provide free off-charts open source based tool chain and Eclipse based environment to use the course on your site without need to buy commercial license. New thing what we are working on to support in our course is the Nexus Trace. Early version is already available for the customers, and we are plan to release it in the mid of this year. Another processor which I mentioned, which is under development and plan to having engineering samples by the end of this year, beginning of next year. It's Linux capable processor, which is a dual core BI671 out of the CPU running at 1 GHz at the worst conditional silicon. And it's also contain the security and real-time core BR351, which cares about security boot processors and the crypto management and also real-time applications. So this CPU will have quite rich set of peripherals, and It more targets for as a general purpose small Linux processor, secure gateway processor. It will have some crypto acceleration, so it can be used in the VPNs and industrial automation and providing the different user interfaces in the industrial automation environment. So at this chip, we built for the customer several subsystems, and one, of course, it's Linux capable cores, which are about 1.5, 1.8 times faster than ARM A53, and then the same level of ARM A73 cores. But we also do the security subsystem, which isolated enclave inside CPU, which cares about secure boot operation, providing the crypto services to the overall SoC, and its isolation is programmable. So its isolation is based on IOPMP, which limit access to the TCM memories of this security subsystem for external masters. Besides the security work, this core can do real-time tasks to offload them from the main CPU. And there is easy synchronization mechanisms between BI671 and BR351, basically based on atomic operations of a RISC-V extension, which you can perform from the both cores directly in the TCM memories of BR core. So BI core can access, if it's allowed by IOPMP, TCM memory of BR351 and do some synchronization algorithm. So another application is also connected to the secure boot, but here we more use more small core were required, and the 64-bit requirement from the customer was mandatory, because the system, the core should also manage the subsystem, which has 64-bit address space, and we need to support it inside the core to easily access it from the security subsystem. This core was also extended by B extension to speed up cryptographic algorithms, and we also implement custom crypto extension of our Russian national standards. Example of this work is shown at this slide. So we added custom instructions to support our local cryptographic standards in the BM610 core. So we added about 10 instructions which focus on the cipher algorithms and hash algorithms. And we also use power of B extension to speed up some operations. Note that we implement all this across all tool chains, so it's integrated into the assembler, GCC, and we're providing the intrinsic functions and some library to the customer, which allow to run these algorithms at the CPU. So overall, we got about 100-time improvement in the encryption speed comparing to pure RISC-V IMC implementation, about 50 times hashing performance improvement. So as you can see, and there is some links to related work which people before done in the Intel machines, we got about 60% of Intel performance at the very tiny core, which is less 0.1 millimeter and 28 nanometer. And that's all allowed by power of custom instructions. Note that it's only example, and CloudBEAR provide a turnkey service for the customers to implement the custom instructions, validate them, and integrate them into toolchain, and provide you complete solution to speed up your own workloads, which you feel differentiate your product. And the last example, which I would like to explain you, is industrial automation SoC, which is under development at the customer. It's based on the dual core BR351. So one core is focused on the networking and another on application itself. We enabled many features inside this IP. So we provide instruction caches as aggressive prefetch for embedded flash. We enable PMP for running the some secure software which isolate the application processors between inside CPU and also between CPUs. Some low latency features, which is based on N extensions, which allow faster interrupt in the user mode, and providing direct access to these DCM memories from external masters. Atomics are also supported not only inside the cores, but also on the buses, and you can easily synchronize between two cores directly via TCM memories coupled with these cores. So that's basically what I want to present today. And please visit our website if you want to learn more about the course, and write us on the info@cloudbear.ru. Also, please join us at Twitter. So there is also many news there coming up, and yeah, please feel free to ask the questions.
Thank you for a good and impressive presentation, which says many cores already designed. So, question from audience. Right now, nothing special. So I have several questions to you. So, yeah, first one is so your IP was designed as such a secure functions. So, is a secure functions mainly for cryptographic processor or something? Or as a function, yeah.
Yeah, so for one of the cases, we added our local. In Russia, we have local standards for cryptographic, so that's its national standards. So it's typically doesn't supported by other CPUs which are available in the market. So for customer was really important to add it because it's used in industrial automation products, which should be certified in Russia to be used and it should integrate local cryptographic algorithms. But in general purpose machine is quite slow, so we added custom instructions to support this kind of algorithms to speed up it.
So in your country, a kind of standard or some rule or some circumstances about security. So is there already some standard tests for checking security or so? Standard test means that it's a kind of standard company or government recognize that this is secure or so. Is there such kind of test?
Yes, there is some certification process. That's right. And if you claim that it's secure, it should pass some independent tests.
So then, currently your product is just coming to the real market, and it's just before the starting to produce an actual product, or such a just a prototype.
So Yeah, for first applications or deeply embedded cases, we got several licensed cases. It's worldwide, so it's not only local use cases, but typically these applications are kind of when you don't see CPU from outside world. So it's do some management work, control work, and yeah, people are licensing it for to do that. For devices which I explained in the presentation, it's another thing. So the cores are visible and programmable. So it's a little bit longer time to market for them because customers of our customers should take these chips, write their software, and then they go to the mass production. And first examples are already in there. So it's a smart metering chip, as I explained, and this summer it's planned to start mass production already on this chip because customer already give the feedbacks. They try it on their site. They port their software to RISC-V, and now everything is ready to ship that to the high volume.
So then you already have a good prospect of potential customers who will use your products right now. Oh.
Yes, yes.
Very good situation. So then your IP designed include RISC-V spec or so. Then do you or your team design the RISC-V core by yourself, or
yes, it's fully our design. It's written and system Verilog and designed completely inside the company from the ground zero. So it's full RTL code is written in the company.
Okay, great. So that's all for my question. So yeah, thank you so much for the good presentation and the bright future to your mass production company. So thank you for a good presentation. Yeah.
Thank you.